Activity 2, the switch. Won't be able to show you like the actual switches, how to wire them up. If you want help with that, just grab me during class. Switch that would control all 3 bulbs at once. This is switch M. So it can go anywhere along this main line, right? The wires that lead to and from the battery. The 2 wires that lead from the generator to the first bulb. Please don't draw switches in corners of circuits. Switch that would control only bulb A would go either here or there. Switch B, either there or there, okay, on the wires leading to or from bulb B, C. This is all the same stuff, okay? So this could either go there, 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 or there, because all those wires lead to or from bulb C, okay? In each one of these cases, like if you want to control bulb B, you actually have like 2 wires clipped together on the switch. You take it off, put the switch in, connect those 2 wires back to the switch, and then use your additional wire to go from the switch to the bulb. Bulbs B and C, so that has to go in a place that is either carrying current to the 2 bulbs B and C or from it. So it would go either here or there. So I'm putting all my switches on the right side, so I'll keep doing that, right? So if this switch were open, current could still flow, and neither of these were here. Current could still flow through A, but wouldn't be able to make it to B and C. This is a throwback to activity 1 on how current flows in parallel circuits. This is crucial to this unit, knowing how to do this stuff. So here we have total current of 12.3 amps. And you should have learned from activity 1 that whenever you have, say, a 3-branch circuit, 3 bulbs or resistors in parallel, the total current gets split evenly between those pathways. Okay, so if you have 3 pathways, then it gets split into thirds. If you were to have 5 pathways, 5 bulbs in parallel, it would get split into fifths and so on, okay? So this total current A equals 12.3 amps, leaves the battery, goes around, comes to here. At this point, since we know we have 3 pathways, it gets split into thirds, okay? So a third drops off. 4.1 amps drops off and goes through B. So 4.1 drops off. What carries on? Well, the other 2 thirds. So you can do 12.3 minus 4.1 and you get 8.2. So 8.2 carries on. It's the same on the other side. We could put 8.2 down for D. And then another third splits off. Yeah, 4.1 drops off to the second bulb, and then the remaining 4.1 goes through C. Yeah, so again, 12.3 comes around. 4.1, a third of that drops off. So 4.1, then 4.1 and 4.1. Okay. And then they start adding back up again when you come around. So 4.1 comes around, joins up with 4.1 from the second bulb. 4.1 plus 4.1 makes 8.2. And that's what I have for D already. 8.2 is coming down, and then another 4.1 joins up with that, making 8.2 plus 4.1 gives you your total again. So E is 12.3 amps. Number 2, the given current is along this pathway right here, leading to the 2 remaining bulbs. This is 3 amps going up to those 2. So you know that 3 amps is going to be split evenly between the remaining 2 bulbs. So 3 divided by 2 gives you 1.5, right? So now we know 1.5 is flowing through each of those pathways. So we know E and we know D are both 1.5. 1.5 coming back together again, join up to make 3. Notice how it's symmetrical. It's the same as on the other side. 3. And then we know this has got to be 1.5 as well, because each pathway is going to carry the same current. That current gets split evenly between all the pathways. So C actually is 1.5. And then if you add up that third 1.5 rejoining, so we have 3 plus 1.5 gives us a total of 4.5. Okay, which is the total current that flows through this main line and through A. Last one, 3. D, the current flowing through this pathway is 0.24 amps. That should clue you in that every other pathway is going to have that much current too. So there's going to be 0.24 flowing through this as well. But what you really got to notice, this pathway is open, so that means no current can flow through it. So really you can ignore that and realize, treat this as a 2-pathway parallel circuit. So really, C is on the same path as D. Current, this 0.24 came from like down here. It just bypassed that open pathway, looped around and loops around, you know. So really C is 0.24 as well. They're on the same line, you know. You wouldn't lose any along that way because this is open. So C is 0.24. 0.24 comes around. Of course, like none joins up from that path because it's open. So this is still 0.24. And this pathway is carrying 0.24 as well because we know the current is even between the closed pathways. 0.24 plus 0.24 should give you 0.48 for the total. A and B are 0.48.